G'day team, welcome back to another video, and we're actually going to start diving into the realm of calculus and differential calculus with derivatives, limits, all sorts of good fun. But to start with, we want to get a bit of a base on rate of change. So a rate is a comparison between two quantities with different units. And I've got a bit of an example here. So I've got two quantities. I've got time in seconds and I've got volume in liters. Now we're going to look at three different kinds of rates of change. And to start with, we're going to look at constant rates of change. So I've got a nice table full of data here. So time is measured every 5 seconds, and the filling bucket volume is measured in those 5-second periods. So I've gone ahead and graphed it. So we can see we get a nice linear sort of relationship. So we can say that the volume changes the same every time increment, or there's a constant gradient. This also means the rate of change is constant. So we can sort of look at the rate of change as being a gradient or a slope of our line. Now, hopefully you remember this formula here for our slope. Or our rate of change is y2 take y1 over x2 take x1. So let's have a look at an example. So find the rate of change in the example above. So because I've got x1, y1, x2, y2, I need to choose 2 points. So I need an x1, y1, and I need an x2 and a y2. Now, x1, y1 must be the leftmost point, and then x2, y2 is the rightmost point. The easiest point to choose is always something that has a 0 in it. So I'm going to choose 0, 0 to be my x1, y1. And then, because it's a constant rate of change, I can pick any point along this line. So I'm going to choose this point in here, which is 5 and 2. So 5 and 2. So, using my rate of change formula, I've got y2, which is 2 minus 0 all over 5 minus 0, which is 2/5 liters per second. Because I've got y over x, I've got liters over seconds. So that's how much my bucket is filling up per second. So 2/5 liters per second. One thing we can also look at is a varying rate of change. Now, with a constant rate of change, it's really easy to find a slope or a gradient because it's a straight line. But when I'm looking at a curve like this, it's a little bit different. So we would say this isn't a constant rate of change. It's a varying rate of change. So we can find our average rate of change from two specific points by having the coordinate of those 2 points and using those in my y2 will take y1 over x2 take x1. And that's essentially what this equation here is. So f of b is y2, f of a is y1, and they're just the y values at my given x points. So let's have a look at an equation. Or an example. So find the average rate of change between x equals 3 and x equals 5 for y equals x minus 1 times x minus 4. Now, to find the average rate of change, we need f of b take f of a all over b take a. Now, a is my leftmost point, and looking at x equals 3 and x equals 5, x equals 3 is going to be my a. So to find f of 3, we need to substitute it into my equation. So I will have 3 minus 1 times by 3 minus 4. 3 minus 1 is 2. 3 minus 4 is -1, so I'm left with -2. Now, b is going to be 5. So that means I've got f of 5. Now, instead of substituting in 3 for x, we're going to substitute in 5. So 5 minus 1, and then 5 minus 4. So then I've got 4 here times by +1, which is 4. So I've got my a value, my f of a value, my b value, and my f of b value. Let's substitute them into my formula. So f of b we said was 4 minus f of a, which is -2, all over b, which is 5 minus 3. Now 4, subtract a negative number gives me a positive, so I've got 4 plus 2, which is 6, and 5 minus 3 is 2. So that means my average rate of change between x equals 3, which is about here, to x equals 5, which is about here, so that nice straight line through there, is 3. Yeah, it's 3, okay. Now, it's not 3 along the whole way, because here it's obviously a little bit shallower than it is here where it's a bit steeper, but the average rate of change is 3. The final one we are going to look at is instantaneous rates of change. Now, we're still going to be looking at our curved functions like this, but we want to know the rate of change at a specific point A. Now, what we've been doing is finding the slope between 2 points, but when we're looking at just a single point, we can draw a tangent. So a tangent is a line that touches my curve, and we can find the gradient of that tangent. So to find the rate of change at A, we need to find the gradient of the tangent at A. So we need 2 points on my tangent line. So we're going to find the instantaneous rate of change at A on the graph above. So looking at this little need section here, we need 2 points on my line. Now try and pick some nice integer points. All right, now it has been moved, so it's probably going to be a little bit tricky to see, but let's just adjust it a little bit so it's in a nice little corner. All right, so we want to pick sort of 2 known points. Now, it's still a little bit off, and I don't really know why. There we go. That looks a bit nicer. So there's a few points that we can look at. We can look at this point here. We can look at this point here that we know, or we could look at this point over here. Now, there's obviously a few to choose from, so let's choose the 2 easiest ones. Let's go with this one, which is 3 and 3, halfway through, and then this one here as well, which is 5 and 5. All right, the scaling's a little bit off, but just trust me on that one. So we've got 3, 3, and we've got 5, 5. So if I'm going my gradient formula, so that's my y2 take y1 over x2 take x1, I end up with 5 take 3 over 5 take 3, which is equal to 1. Okay, so the instantaneous rate of change at A is 1 because the gradient of my tangent at that point is 1. So with that, here are some questions that you can do in the Hazy textbook. I will see you guys in the next video. Thanks for watching.